The second and also very important comparison theorem, okay, it has a slight name change. Instead of the comparison test, it's called the limit comparison test. And unlike the other one, we don't add and subtract to compare. We just divide. And when you divide it, and you take the limit of that function of n, right? And you get a positive constant. It doesn't matter what it is, as long as it's positive, then they're both going to converge or both going to diverge. So if you're trying to figure out the limit of this, the infinite sum of this, but you don't know how to do that, but you know for a fact this one is, let's say, converging or diverging. And after that, you gotta see, well, can I find the limit of the ratio? If the answer is yes, then you have something to compare it to. Okay, so let's do an example like that. Here's an example where we would have very hard time comparing this with another function that we know that will converge or diverge. Sorry, yeah, it's just n here, not n to the power of n. Okay. So what should we compare this with? What part looks easy? What part makes it look confusing? E to the power 1 over n, right? But as we increase n, right? What happens to e to the power 1 over n?
Approaches the 1.
E to the power approaches 0, right? This approaches 0, so it'll approach 1, right? So that actually tells us, you know what? Maybe it's actually pretty good to compare this with, so let's let an equal to 1 over n. Right? Because this is sort of becoming closer to 1 over n, right? As n goes to forever. Now that's a good sign because we have to do a limit on their quotient. So they both better be approaching a similar number so that when you divide it, it becomes a number. If one gets really big, or both gets, and then this one is just a number, there's no way if you divide that, you're going to get a number. Right? So you have to kind of have a sense that they're both approaching 0 or they're both approaching infinity. Okay? Alright, so let's do the quotient. We're letting this be bn. Okay, and let's do an over bn. An over bn is going to be 1 over n. And we're going to get 1 over e to the power 1 over n. Now you do the limit. Like that. And we're going to get 1 over 1, right? It's a constant that's greater than 0. So what's the conclusion? Okay, they're both diverging. Good. Because we know that this is harmonic series, right? So therefore, we can say that right there is diverging. Okay, diverging. Say diverging by limit comparison theorem.